Okay, thank you so much, Sungwo, and thank you, Mr. Park, Mr. Hogul Park, for calling together this special STEAM seminar again. So for those who are first-timers here, warm welcome in our STEAM community. I hope you will join regularly from now on. So this seminar started some half a year ago. It's quite amazing to think about that. It's already going on for half a year now, and we try to meet in every month, and we try to bring together teachers, educators, parents, children, so all who might be interested in quality education, especially integration in education, what we can call also as STEAM, so the integration between science, technology, engineering, arts, and mathematics, but we can also call it in many names. The most important probably is the active learning and the collaboration during learning, collaboration on the teachers level, collaborations on the children level in problem-solving activities, and also collaborating with the parents. And there's so many things happening nowadays in education, and also the word pandemic was a big game changer in every of these developments and trends. We just found important that this is an opportunity to bring together these people and have these regular discussions. So we are together with Mr. Park and his team from Korea, Seoul, 4D Frame team, and Experience Workshop team, Chris Brownell from Fresno, US, and many of you. We try to invite those speakers, those projects, which we think that they could be good conversation starters. And the main goal is to have this conversation going on, and also to have more communication also in this group of people who are caring about the future of education. So our host is regularly Chris Brownell. I also try to help out with my broken English. So it's time to pass on to Chris. And I guess Nora will also tell us about the schedule of this event. And then we just starting up right in the middle. So Chris, the floor is yours. Thank you.
Thank you, Kristof. Greetings, everyone. Welcome. I would like to say welcome from California, but I'm not hosting this beyond being the face and the voice of the special seminars. This has been a real treat to be able to join you all from everywhere. Today, it feels like it's becoming so common. We're almost an everyday feeling like we all join together, despite the fact that we live completely around the globe, to see these efforts to strengthen education in STEAM or integrated education or convergent education. All of these ideas coming together in this time. Today we're going to see a particular collection of ideas that Nora has been particularly involved in. She's going to sort of lead us through the talk from the start. So Nora, would you introduce yourself and then a little bit about Mathena and the Mathena team?
Yes, I will be very brief. My name is Dora Somjodi, and I am the CEO of Experience Workshop in Finland. So I'm running Experience Workshop together with Kristof Fenyvesi. I will soon pass the word to Daniel Ramos, who is from Imaginary. Imaginary is the coordinator of our project, Martina. So he will do a more detailed introduction, but shortly about the schedule. Daniel talks, let's say, about 10-15 minutes about Martina. Then it will be our turn with Kristof to talk about Logicity, which is Experience Workshop's contribution to Martina. Then we will continue with Carrie Osborne's presentation. She conducted the focus groups for us of Logicity stories in Helsinki. Then we move on to another land in Martina, the land of the Firebirds, presented by Daniel Ramos again. Then we move on to cryptography, presented by Ricardo Moschetti from Italy. And finally, we will hear Ana Cristina Oliveira from Attractor in Portugal, and she will present Exploring Symmetry. That's our schedule for today, and there will be time enough to discuss any questions you come up with.
Chris, are you excited to hear about Firebirds, Symmetry, Martina, all of these, cryptography? So there were so many exciting words here. And where do these connects to? This is
how do they all come together in one project? This is an exciting thing. What a wonderful idea.
Okay.
I'm on the edge of my seat, as we say.
Okay. So the floor is for Daniel Ramos, who was coordinating all different components together and kept together this big architecture of this project. Thank you.
Okay, thank you very much. I hope you can hear me. I will share my screen shortly. I hope everything works. I think you are hosting and coordinating all the infrastructure, I hope.
We'll take care of it.
Great. So just a couple of words of me. I'm Daniel Ramos. I'm Chief Content Officer for Imaginary. Imaginary is a German non-profit association for communication of mathematics. I will talk a bit later about Imaginary in my section about the Imaginary contribution to the project Martina. So just to say from me that I'm a mathematician by training, and I have been now working for almost 8 years full time on communication of science and mathematics. So Imaginary has been the lead partner on this Erasmus Plus project, and we have been coordinating this Martina project. So I will make a quick tour on what is the project and how it is. So let me share my screen. You should be watching my presentation now.
Yes, we are. See it.
Good. So Martina. What is Martina? Martina, an interactive storybook between mathematics and fantasy. So what is Martina? Let's change the question to who is Martina. So Martina is this young lady. She's a teenager. She likes going around with Leo. Leo is her brother, and they together find a lot of adventures and mathematical riddles everywhere they go. Where? Well, they live in this fantasy land. This is Platonia. It's a fantasy land full of strange creatures like dragons, wizards, pirates, big cities, and it's a fantastic land where, well, besides all of these fantastic creatures, there is the particularity that everything is ruled by logic and they find a lot of riddles and a lot of mathematical questions or riddles everywhere. So this is more or less what is Martina, what is she doing? So for us that we are here in the education field, so what is Martina really? So this is our approach to having a non-formal math education using fiction stories and interactive apps. So this is the proposal that we have. This is an Erasmus Plus project that we have developed between these 5 partners. I belong to Imaginary, the first one here. We are from Germany. Then we have Attractor from Portugal, Curvilinea from Italy, and Experience Workshops from Finland. We are the 3 in charge of the content and the education, and we have also Bragi, which is our technical partner that has been taking care of the infrastructure and making sure that everything looks great on the screen. So what is Martina then? It's a collection of stories for children, a wide range of ages from 4 to 19 years old, trying to bring mathematical ideas to children. We are using some interactive apps, some games, and some things that you can play on the computer. And then together we bundle some content for the educators, so that we can collaborate with the formal education. So we have an online guide, and then we have a handbook. And we are now doing some workshops on some pilot tests of the materials with children, and we have some community support. And I'm going to be sharing also here. This is matina.eu. This is the main website where you can enter, and then you can discover all about the project. And it's the main big button here will bring you to this Adventures of Martina. So this is more or less the main product, if you want to see it in this way. It's this is where you can enter, and then you can explore different stories. And on each of these places, you will discover like a storybook. It's like a story you can read. And then you find some animations, and the characters Martina and Leo, they are going around and they are finding some friends, and they are finding some people, and they find some riddles that they have to solve. So we will go through all these stories. We have this nice artwork here that really we try to make it look like a storybook for children. And then you will see that we have also some games and some apps that are also have this aesthetic. So this is the main idea of what is Martina. It is our idea for bringing mathematical ideas to this non-formal setting. So I would like to just to give briefly some ideas of the principles that we have been following for having this project. First is that Martina is mainly a non-formal learning tool. It is, of course, you can collaborate with the formal system, so you can collaborate with the schools and you can collaborate with educators, but it is also something that parents can use, and it is something that you can do outside of the classroom. And this is the main idea that we have been trying to develop. We have this combination of learning and entertainment through stories. So since we are in this non-formal setting, we need to convince the public or the children that this is attractive. So we have to get their attention, and we think that these stories fulfill quite well this task, because just the story by itself is interesting, and then you have these puzzles that you can try to solve through these interactive apps, and then it is something that pushes you to take some action and immerses you in the story. But just the story by itself is interesting. So this also levels up everybody, because you can follow the story just reading it. And the third key concept that I would like to stress is this early introduction of mathematical concepts. So since we are in non-formal, we don't need a ground for building the mathematical concepts. So we can play around, and you will see that we can play with the ideas about integration, or we can play about vector arithmetic, or we can talk about cryptography, or we can talk about many mathematical concepts that we don't need to have this ground to build on as you need in the school, because in the school you have this constructive approach that you have to explain everything about this concept. You have to master this the ideas. Here we don't need to master any concept. We just have a very brief introduction. So for this idea of non-formal learning, mainly the key drivers are sparking curiosity, developing this reasoning and abstract thinking skills, and reviving this interest in mathematics. Yeah, it's again, this is basically non-formal. Of course, here in this meeting, we all know what it's non-formal learning, and it's not just a question of whether it is in the school or it is at home. Is what can you do on this education? What can you learn, and what can you experience? So we are touching shallowly a lot of domains of mathematics, with the idea that people get the interest, and that the people want to learn more about these topics, or that they have some intuition in the background of their heads. So this is for the non-formal learning. How do we do that with these stories? Well, when we have this combination of learning and entertainment on stories, we have this kind of fundamental problem that we aim to a very wide range of target ages, from 4 to 19. Then, of course, how can you make something that works well with a 4-year-old, which they cannot even read? So they need the parent together, and they need to help to understand the stories. And then you have an adolescent of 19 years old, which has some other problems in life and other interests. So how can we make things that work for everybody? Well, the stories are graded by age. So there are stories more appropriate for younger children, and other stories appropriate for older children. But at the same time, the stories are never too easy or too difficult. So actually, you can read a story which is easy for you because you understand everything. It doesn't pose you a challenge, but anyway, you can enjoy a story. And the children, they can also read the story which is meant for elder students. And even if they cannot solve the riddles, because maybe it's a lot of conceptual hassle for them, but they can still see the pictures, see what is going on the story, and they can get what is happening. And if they are talking about whatever, cryptography, for instance, maybe they cannot solve the problem of cryptography, and they cannot understand this cryptographic system that is the goal of the apps. But they can know, but they can understand what is happening on the story. The story, there is someone who has some problems with cryptography. They want to hide a message or something. So the story is accessible to everybody. And so on this spirit, the games are challenging, or can be challenging, but they are always non-blocking. So you can always continue with the stories. And the mathematical concept appears naturally. It's not that okay, you are in your life and then suddenly a math problem pops up and you have to solve it to continue. It is something that it is embedded in the story. So the creatures that you find, they have some mathematical properties that they kind of appear naturally. We will see the examples later. And this third idea that I was mentioning before, this early introduction of mathematical concepts. Yeah, so we try to introduce concepts much earlier of what they will find them in the school, in the formal system. So if, for instance, they find the negative numbers at fourth or fifth grade, we can introduce it much earlier. We can introduce it for 7 years old. If they will discover functions at, let's say, at 13 or 14 years old, we can introduce it earlier. And the same with the derivatives or plenty of concepts. We can treat it shallowly in a way that you gain some intuition. So the goal is that the children gain some intuition on these ideas. So to try to get some more concrete, I will present you the mathematical topics that we decided to have. There are these 4 mathematical topics. First is logic, then symmetry, cryptography, as I was talking, and visualization. Visualization meaning the interplay between symbolic and graphical language in mathematics. Each of these topics has assigned one of these lands. So the Martina and Leo, they go there, and then they find some different characters. They find some different creatures and the people, and they find the different problems in these 4 different regions. Also, each of the partners took care of one of these regions. So the topics could have been different, of course. So I'm not saying that cryptography, for instance, is fundamental in the mathematics education. Well, it's an interesting topic. It's interesting because usually you don't have it in the formal education. So it is something that you can get outside of the classroom. The symmetry, it's the same. You have some formal training about symmetry in the school, but usually you don't go to the degree of detail that we go on these stories. And then the logic, of course, it's the logic is much broader in this sense that the logic and the visualization are 2 of these kind of background skills that you have to develop in mathematics. So having this abstract thinking skills, how do you organize your ideas, and the visualization is similar. It's plenty of mathematical concepts. You have one visual representation, and then you have a symbolic manipulation that you can do, like in a function or like vectors. So vector can be a couple of numbers or can be an arrow. So all this is what we mean with visualization, and all these are kind of background skills that you need to develop in mathematics. So just some examples. So integration, do we talk about integration? Yeah, of course, but what you have here in the left is what you do usually in the formal education. You learn it when you are 16 or 17 years old, maybe just before entering the university. And you have this symbolic manipulation, and then you have some ideas of what does it mean on the graphic. But here on the right, we have our proposal for children from 4 years old. So very young children that they cannot even read. But here you have this vector, which is the speed, and this dragon is flying, following the direction that you are pointing with this arrow. So this is the speed vector. So this is the derivative of your trajectory. So actually here you have an integration. Of course, we are not talking about integration. We are not saying the word integration. We are not saying the derivatives for these children, but we are giving these hints that at some point you will later, maybe you will be able to revisit. And if this story is read by a 19 years old, he maybe even find that, say, what they told them in the school just before entering the university, they say, well, this is integration, and they will just find, okay, so for having this problem, so if I give you the speed vector, what I'm doing here is an integration problem. So even for older children, they can discover something on these stories. The vector arithmetic is another property. So what do you really need from a children to understand that a pair of numbers is an arrow? So this is a key idea. Of course, we are not going through all the vector arithmetic. We are not doing dot product. We are not doing modulus or argument, and we don't have trigonometry here. It's just that this idea that you can have something that it's symbolic and represented by a number, and you can represent it graphically by a vector. And this is something that you can really do very early in the educational life of children. Some problem-solving strategies. This is for solving the problem. You can think it backwards. You can think it forwards. You can rephrase the problems. So these are some of the abstract that we have here. For symmetry structures, my colleague from Attractor will show you some of the things. This is really something that usually it goes beyond what you usually do in school, so you can do it together. But again, it is something that our intention is to have it earlier than what you do in the school. And this cryptography problems, it's the same. So here you have things that it's not even earlier. It's just something that you don't do in the school. Usually you don't do cryptography in school, and it's not because it's difficult. It's just because school is for something else. School is for giving you something which is really fundamental in your education. It prepares you to do further studies, and it's something that is well grounded. But then you don't have the time for doing everything. But it's good that you can get some ideas about cryptography, and then you can have a first introduction here. Of course, in our stories with the pirates, you will not get a deep understanding of cryptography, but you will get a first contact probably. So that's the idea. So just a final list of materials of what can you find on the Matina project. So what we have prepared on this 2 years project that we have been working on that. First is this main storybook that I have been showing you. This is the storybook where you can access to all the stories. Second, we have an educator's online guide. So if you check here, you will see the stories, and you will get the stories for the children. But if you go to the main page, you can have a parallel storybook, let's say. So on this educator's guide, it seems to have the same interface, but when you go to the story, it actually gives you this explanation that it's for the educators. So here you can see all the details, and you can have some videos that are explaining the apps, and so you really have some support if you want to use it with. Especially we are thinking on parents using this with their children. So the parents are not teachers, they don't have a background in mathematics, so they can come here and they can get some ideas and some hints on how to use in these materials. So this is this second online platform. So we have the main interactive storybook, we have this online guide, and then we have a couple of documents in PDF. First is this Matina program booklet. This is something you can find in our website. Just at the bottom here, you can see this was the seminal document that we prepared at the beginning of the project. So here you can see the main ideas for what is this Matina project about. And then in a matter of days or 1 or 2 weeks, we will release this educator's handbook, which goes beyond what it's on the online guide, and it gives some additional resources that how can you use and expand Matina in the education. And so this is the materials that you can see and download from the internet. We are also doing some workshops now that we are doing these focus groups, and we will plan to do something now that the project is coming to an end. So we are planning the afterlife of the project. We have a Facebook page where we are we are eager to start collecting feedback now that people is starting to using these materials. So we have prepared this Facebook page. You also have it on the main website. Here you can go to the Facebook page. Yeah, this one. And yes, and then we have a small YouTube channel with some demos of the apps. So this is an additional helpful resource for what we have. And that's all. So just you can go to this mathina.eu website, and then you can get all of these materials and play a little bit with the stories and read about these stories. So that was my presentation for this general overview.
Thank you a lot, Daniel. Meanwhile, there were a lot of reactions in the chat. You might want to check it out. So people seem to be enthusiastic to learn about all of this. If you will have the opportunity to put this link also in the chat, I think it will help to the people to check out all these connections. So we are moving on now, and this is Nora Shomyodi's round from Experience Workshop, if I'm correct, and I will manage the screen sharing. Daniel, if you could stop your screen sharing, I can start this other one. And here we are. The floor is yours, Nora.
Hello again, everybody. Thanks for joining us today. I will briefly introduce you to our field, Experience Workshops field in Mathina, which is Logic, and our realm is called Logicity. Please show the next slide. So this is the main page that you encounter. As you see, it has been refreshed since last night when I took this screenshot. So Daniel's image was a lot nicer than this one. So on the top right quarter, you see Logicity, and we have developed 4 stories for different age groups and with different mathematical problems. Let's go on to the next slide. First, a few words about our team. Kristof Fenyvesi is known to most of you. He is a STEAM researcher at the University of Jyväskylä in Finland. And he is the founder of Experience Workshop. I am the CEO of Experience Workshop, Nora Shomyodi, and I was coordinating Logicity. I don't have any backgrounds in mathematics, or I don't have more than anybody else who has attended primary and secondary school. I am a journalist. I was working as an investigative journalist for quite a long time before I moved to Finland, and then I changed my profession. And I am what am I now? Project coordinator for Experience Workshop and manager of the company. But luckily enough, if we go to the next slide, you will see that we had a really nice team of mathematicians working with us. The first person I would like to introduce is Anna Mécs. She is a Hungarian writer. She is a well-known name among the young generation of writers. But differently from most of the people in her generation, she's also a mathematician. She wrote her thesis about storytelling and mathematics. But at a certain point, she decided not to continue her career in math, but she became a writer. At some initial point of Mathina, we decided that we would like to work with a real author, so that we won't write our stories ourselves, but would like to cooperate with someone who knows more about writing stories. So luckily we found Anna. And then the second main character in creating our stories is Sándor Róka. He is a Hungarian mathematician, and he is an expert in mathematical thinking development. He has written countless books, and he has organized the mathematical Olympics. So these two people work together in writing, selecting, collecting mathematical problems for our stories, and it was a cooperation in our team finding the final problems that then in the end found their way to the stories. Of course, I have to also mention that we had to face some compromise. So the stories that Anna has written for us are beautiful to read. But of course, if you do the technical implementation of a story, then it had to be shortened and simplified to some extent. Okay, let's proceed to our colleague Ricardo Moschetti. Ricardo is a mathematician from Italy, and he works for Curvilinea. Curvilinea is the Italian partner in Matina, and he developed the apps for Logicity, and I cannot say thank you enough times to Ricardo for doing doing all the apps for us. And then a short word about Carrie Osborne, the next slide, and Carrie will be presenting soon after us. Carrie is a teacher. She has a British American background, and she lives, teaches, learns in Helsinki, and she is the one who did workshops with children with Logicity stories, and in a good moment, so she was able to work physically together with the children in spite of the pandemic, and she will tell you more about this. Briefly, I introduce our 4 stories. The first one is meant for age group 4 to 6, and it's entitled The Traffic Light Challenge. Here you see Martina and Leo. This is only a screenshot, so this story also has animations and apps. But the screenshot shows that the 2 kids they have walked the city of the Logicity with their guide, the kangaroo, and they face a last challenge before being able to grab an ice cream. And the challenge is a combinatorics problem. So they should find out how many variations they can create from a 3-colored traffic lamp ahead of them. So if we click on the next slide, then you see how you enter to the app, and then Kristof shows you the first video, Logi 1, and then you see how the app works in reality. And all of our stories include several versions of the same app. So this is the first one, and later on during this story, it's possible to try 2 more specific versions of this app. And of course, if we talk about the age group 4 to 6, which is like in most countries preschool, then when children are not yet ready to read by themselves, then that's a good moment to play the game together with a parent or an older sister or brother or teacher. So that's how the app works. So you are able to color the blank traffic light. Go back to the first one, Kristof, please. Okay, so maybe we can watch it again. So it's possible to color the traffic lights, and it's possible to remove a color if you were mistaken, and it's also possible to drag it to the dustbin if you think you were mistaken, but this first version has no right or wrong solution. So this is for a first try for experimenting with the colors. Let's move to the second story, which is meant for the age group 7 to 10. And the title is, what's the title? The title is The Tiled Floor Trap. And here again, we encounter Martina and Leo, and they would like to pass to the building on the right, which has a strange label, UTIC Eagle or ITIC Eagle, but obviously it's Logicity, just the other way around. And in order to pass there, they have to go through a pattern, which has a certain rule. The story encourages children to think the other way around, so to use reverse thinking. And if we proceed, then we see the pattern we see the application. Yes. And here Leo is trying to find the right way from the end to the beginning. And the rule is that he can only move between identically colored fields or between identical shapes. And now he succeeds and arrives at the beginning. So this app also has two versions throughout the story. I think we can move to the third story for the next age group, and that's from 11 to 14, and it's entitled Cats and Dogs. And this story focuses on the art gallery problem. On this image, you see the layout of Logicity streets, and you see a lot of characters. You see two policemen on the right, and you see Martina, you see Leo, and you see a thief in the center. The thief has stolen all even numbers from Logicity. And the policemen are chasing him, and Martina and Leo try to help them. And it turns out, of course, that two policemen are not enough to patrol all those streets. Let's go to the app. Not this one, but this one. And here you see two hats symbolizing the two policemen. And here users can make a try whether it is possible to patrol all those streets if it's only two policemen. And by dragging the hat, the streets patrolled get highlighted. And of course, it's not possible, so you need more policemen, but this can be experimented with in another application, which you will be free to try later on. And let's move to the last story, which is for the age group 15 to 19, and it's entitled My God, Please. Here, Martina and Leo encounter Logicity's soccer team and their trainer. And the team has received an enormous amount of gold medals. And the trainer explains how they will share this amount of gold medals. And this story focuses on the divisibility rule by 9. And the boys don't get the point, so they don't know how to solve this problem, but Martina is there to help them. So the first team member receives the sum of the digits of the number of gold medals the entire team has received, and then the second one receives that much less from the total number, and so on and so forth. And if we go to the application video, then you see that you can generate a table and experiment with those numbers. And then enter the sum of the digits of this number, and then again, and so on and so forth. So this app appears several times during the story, and users can experiment with it. Okay, I think we have seen enough of this app, and I also let Kristof speak a bit about our pedagogical goal with all these stories. Thank you for listening to me.
Thank you very much, Nora. I think we are a little bit over time now, according to your schedule. So I just try to wrap it up very quickly. So as many of you know already, Experience Workshop, we are very much focusing on active learning. So how to involve, how to engage children into learning, and of course this is goes natural when you come together physically and you have all these physical activities and all these wonderful modeling tools, what you can also see on this picture. But it was a new adventure for us, and that's why we were really happy to teamed up with Imaginary and Attractor, who has more experience also in this digital engagement and how to engage children in digital activities as well. So this was a new way for us to combine these approaches. And actually the involvement of these key people like Anna Mech, the writer, and Sándor Róka, the problem-solving education expert, was a really nice combination to start this, because there are many studies already in neuropsychology, in cognitive psychology, about how the brain learns. And of course, we know it from these studies that the brain keep making narratives, keep making stories, keep organizing information into various structures. And we also know it from the history, from experience, that, for example, if you think about the history of mathematics and the history of famous problems of the mathematics, it's usually somehow embedded into different kind of stories, different kind of anecdotes. Of course, the whole scene has changed with modern science, and we are not anymore can tell the stories related to abstract mathematics. But still, if we would try to invent also a lot of more stories to introduce children to these problems, maybe that could be a natural way to open up mathematical beauty for the children and the people. And our approach was concentrated that, for example, in small children, it's very basic and very important thing that parents and children and teachers and children share stories, and they learn through stories and related activities to these stories, and they start to play around with the stories. And in this kind of approach, the help of the writer and the problem-solving expert, who has already had a lot of books in connection with logi stories. That's how he calls them, that those kind of stories what make you think, make you engage, those kind of riddles, what you are motivated to find out, like who done it ways. And we tried to systemize these approaches and bring it into this experience-oriented format in the form of these activities. So it was mainly experience workshops contribution related to logics. We have other Erasmus Plus projects also going on, because this all has been supported by the European Commission. So we also found a lot of connections with our other projects, which you can see on the screen. And I think it's really the time to give the floor to the next speaker. And in the conversation, in the question and answers part, we can discuss more details later. So who's our next speaker, Nora?
Yes, I would like to invite Carrie Osborne.
Okay.
To
Carrie,
speech.
will you share your own presentation in your own screen, or do you want me to share your presentation here?
Either way is fine. I think I can share my screen, but it's fine
Okay.
if you
Yeah. Please try then to share your screen, and if anything I can help, I'm here with your presentation too.
Thank you. You're always always there.
Yeah, let's hope.
Can you see now?
Yes, absolutely. Perfect.
Yes.
Perfect.
Yes, we're good.
Yes. Okay. Lovely. Okay. I am an international educator, as you were saying, and so I have taught or I've worked with within the Helsinki school system as well. And so I was able with former colleagues to come in and to, in this first piece, this is a grade 2 class. And in this second piece, this is a grade 6 class. And in this third piece, this is a year 10 or grade 10 class. And so I was able to work with these kids as the focus. So I had a set of questions where I asked them, did they like the story? And there was a resounding, yeah. So the first group that I saw was grade 1, but this is actually this is the grade 1 class down here, and this is the grade 2 class. And they really liked, they said, yeah, the author offered us a way to see things from another direction. So it was really cool. And it was also reverse. There's a lot of, in Finland, we do a lot of, they restructured the curriculum 3 years ago, where they have now a lot of phenomena-based learning as well. And so this idea of having whimsical pieces of how we can look at a big piece in the phenomena of learning as well. So it was a reverse back way round day. So it's not that people in Helsinki are a little bit odd. You can see that her shirt is inside out in this one. But they really loved also then that the story was a backwards way round story. So they said, yeah, the author offered us a way to see things from another direction too. In Finland, whenever I was using English, many of the children, when they restructured the curriculum, children are taught English from the first year of school. And so that wasn't at all a problem or a component of difficulties. So this idea of seeing things in multiple perspectives, as you can see, it's a very, this is what's the Maunala is the neighborhood, and it's a very diverse group of children. This is the grade 1 class, and this is the grade 2 class here. So I said about the length of the story, it was perfect. So it was very nice experience with the grade 1. So continuing on, so 4 classrooms, 3 schools, and these are the names of the schools. So we've just seen Maunala, we're going to go on to Resu. And Resu, oh, there's grade 1 still thinking. Another component. Some people, they noticed this about Helsinki, about Finland. You're able to think more freely, perhaps, because your toes can think also. You come into the classroom and you take off your shoes when you're coming to school here. So it's with the neuroscience also. I know that Kristof was just speaking to that. That's one of the things also that they've noticed, that these kids who have, they're not bound up with constricted thinking or constricted feet, that has perhaps got something to do also with kids being able to see things or being able to experiment more freely and openly. So on to, that was the one that we saw, that was the piece that they were working. So on to this is grade 6. And I worked with this class when they were grade 3, so it was very nice to see them again. Now it's grade 6. At the end of this, the follow-up piece is where they can go and to highlight, I don't know if this highlights that more, but when you go to the end of the Logi puzzle, where that was the patrolling, the way that Nora had told us about the patrolling. There's a place where you can create your own, and there are random links, and the kids had the greatest of fun. But there were some times where it was physically impossible. Again, these kids, they went and they thought, well, how might it be possible? And so one of the students looked up into the address line, and she says, well, basically the link, in the link, the last number is 3. So when you replace the 3 with a 4, it solves it automatically. So this idea of looking to see how you can logically just have things work out. It was very nice to see that also become a component of the class. As you can see also in our, just for worldviews, people in grade 6 now, they're wearing masks, but in grades 1 and 2, only the teachers were wearing the masks, and the students were not. The elementary school students weren't expected to wear face masks, just for a rounded worldview of things. So this is where we saw, what did you think of the illustration? I think the illustrations were too old-fashioned, right? And yeah, it should be, you know, this and this young man here actually, he said, I liked them. I thought they suited the story. So I thought it was a very nice component that, because I remember them as 3rd graders, and I remember that Van Gogh was taught in the curriculum. And I remember that, well, as we know, Van Gogh was completely not liked by many when he was alive. And now, just for those that are in America, there is, I can put it into the chat if you like. There are going to be 13 cities where you can go and see an immersive view of Van Gogh, which is pretty darn cool. It's here, you can see an immersive view of Van Gogh, but I'll put it in the chat later, because I think that it's really cool how these sort of education can encourage you to see things that you've learned previously, and that this arts component can be nurtured through the mathematics component, and vice versa. And then on to when we were onto the English school, which was the grade 10. The grade 10 was the story where we have the trainer who is saying, you must train your mind if you want to train your body. Notice that there were maybe, and this was a neat thing too, because whenever the kids made observations, they also noticed then things changed. Just as Nora said, her screen is different from what Daniel has today shown, because here we have boys, and this is a nice part of the component also, this story. Martina, she's a very, you know, she's a girl, and in Finland we don't have the difference between he and she. If you want to say he is, it's han on. If you want to say she is, it's han on. And so this idea of a girl being somehow lesser, that was one of the pieces that the kids really liked in the story also, is that the girl was smart and she was strong, and she was kids hadn't picked up that they were brother and sister though. They thought that they were just friends. Again, there's more of kids just being kids here, and not necessarily so much of a gender piece attached. So that was an interesting component that was brought up. And I don't know if it was for the Finnish market then that they had changed, because as you can see, there's a disconnect between the illustrations, because I asked them about the illustrations also. And the illustrations, they seem to be rather, and they even call about boys, giving them to the boys. And then when we look at the names, there was a disconnect, but that'll probably, this was the cool thing about it, is that there was a disconnect at times, but then all of a sudden it was like, oh, it's better. It now works. So it was brilliant to be a part of this project. And I think that the kids really enjoyed it. And I was very thrilled that Nora said, "Do you think you can do this?" And I think I can. And then whenever I did, she's like, "You did it." So that was a great part also of all of the pieces, where that was the part that's missing also here, is that at the end, that when the people get older, you stop getting that piece of, you know, oh, you did it, you know, you sort of like are expected to do things kind of. But at the end, like this one doesn't resolve with like, yes, you did it. But I'm sure that'll be fixed too. So
it's corrected already. But thanks for the kids for noticing that there was a mistake in the app.
The kids notice, they're like, but it can't be, because George, the story says that George is fifth and he's not fifth, you know, and the story says that they're boys, but why are there boys and girls? So it's really, whenever you ask for kids' opinions, you get kids' opinions.
Thank you very much, Carrie.
Thank you a lot, Carrie. It's, you know, it's always the big moment to see the children's and teachers' response, and also their involvement also in spotting out.
Okay, I think I have to stop sharing screen now. Is that correct, or did you already take care of that?
No, you will need to stop.
I need to stop. Okay, so I need to go where? Guide me. Where am I going?
Top of the screen should have a big red sign that says
stop sharing. There it is. Well done. Thank you.
Spot on. So I think we've lost Kristof, unfortunately.
I can help you out with.
No, that's quite all right. Okay. I'm used to this. This is fine. After Carrie, we were going to hear again from Danielle regarding the land of the Firebirds. Is that correct? Would you like to give us a little deeper investigation into these burning birds?
Yes, right.
Thank you.
Let me share my screen again. Okay, so yes, I was asked to give a very short brief of what do we do at Imaginary. So you can go to this our website at Imaginary. It's imaginary.org, or you can go to about.imaginary.org to get this screen. This is essentially our splash screen with a presentation. So we are a non-profit based in Berlin, in Germany, although we work internationally. We do science communication and especially mathematics communication. Our main activity is preparing exhibitions. We started in 2008 with the first exhibition. It was prepared by the Mathematics Research Institute in Oberpolfach in the Black Forest in Germany. And since this exhibition, at the moment, Imaginary didn't exist as a company or as an association. It was just the name of the exhibition, and then it grew. Here I have some of the pictures of activities we have been doing. Now we have been doing things in Africa. These are some of the exhibitions. I think this is one of the first exhibitions. I think this is in the train station in Berlin. This is in Korea. This is in Deutsche Museum in Munich, if I'm not wrong. So this is in London. So we have some of these exhibitions. We prepare all these materials, mostly digital things. This is an exhibition. This is an exhibit. This is permanently on the Museum of Mathematics in New York that we prepared. So we do mostly digital things, and now we are also exploring some of physical things, like with 3D sculptures and some stations that we can show in different places. So these are some of the pictures. if we go down, we have some of our latest projects. We have lately done an exhibition on artificial intelligence that unfortunately we had to put it on hold because of the pandemic. So now it is an online exhibition, although it was in the middle of the preparation when the lockdown happened. Another exhibition we had before that was shown for a year, just in 2019. It was about mathematics and music. It was a quite successful exhibition. And we are now preparing a very short museum, like we call it as a 10-minute museum, and we are working on, so this small museum will be about the climate change, about the climate crisis that we have. And other than exhibitions, I can show you here some projects. We lately made an installation in a shopping center in Heidelberg in Germany, putting some math exhibits in a shopping center. We also collaborate in the organization of the International Day of Mathematics, in collaboration with the International Mathematical Union and the UNESCO, who declared this International Day. And now, since this last year that we have been under lockdown, we have been doing a lot of virtual workshops about materials that we have from our exhibitions from artificial intelligence and music mostly. Here, if you are interested, you can see a bit of our journey, our timeline of what we have been doing lately. And this is a world map where we have been putting some of our exhibitions, or some where our materials have been shown. It looks like it's all over the world. The trick is that nobody has been in all these exhibitions. It's just because how we work. So we rely on open licenses and we share everything. So everything we do is under Creative Commons and free software licenses. So everybody can replicate and adapt it. So that's the key for, that's the secret for having exhibitions all over the world. Okay, so this is a little bit of our background, imaginary.org, if you want to know more. And right, and one of the projects we have been doing is Matina. So Matina has this 4 lands here to discover different things, and the one that we have been working is the Birds of Fire. So I will tell you a little bit of why we decided to have this this setup and what do we have there. So yes, the Firebird trainer is the first story. So Martina and Leo were going on a stroll in the fields, and they found this this mysterious lady that was looking to the skies, and they asked her, "Who are you? Are you a warrior? Are you a wizard?" And she said, "Well, I am a Firebird trainer, because there exist these these Firebirds, and the first Firebird that we can find is this Uni Dragon. So, what is that? Oh, that's yeah, this is the Uni Dragon. So it's a mixture of a unicorn and a dragon. And the story goes like this: that these Uni Dragons are like dragons, but they are born with a horn on their heads. Like the milk teeth in the children's, this horn falls at some point in their life when they are getting adult. But this horn that it falls is not a dead material. The dragon still can feel it. And this is the magic one that this lady, Flamma is her name, that she has on their hand. So this is not a magic wand, it's the horn of a Uni Dragon. And the Uni Dragons can still feel it. So since the Uni Dragon can still feel it, you can use it to communicate with the Uni Dragon and they give some instructions. And essentially the key idea is that this horn is a vector. So here we have the idea of direction. Here we have the idea of action to distance. so that the position and the direction are two different magnitudes, two different things. And the story goes explaining a little bit all of this. And then when we go here to fly the Uni Dragon, then we can go to this app that says, well, here you have the dragon that is flying, and here is the magic wand, which is the same as this horn, because it was the horn that the dragon used to have before he was adult. So you can move it, and you can make these curves in the sky, because since it's a firebird, it is burning inside, so it releases some smoke and it stays on the sky. So here we can see this curve that is drawing the Uni Dragon in the sky, and you can see that the horn on the head of the Uni Dragon is parallel to the horn in the hand of Flamma. So this is our story for the youngest children, so 4 to 6. The story can be read by the parents or can be read in the school by the teacher, and the children can play a little bit with this, can play on a touch screen or something, and it is mainly an exercise of coordination between hand and eye. You know, what we are seeing on the screen, what you have to coordinate. It's a psychomotricity exercise on one hand, and then they get this idea of the direction, and you can also change the magnitude of the vector, so you can fly faster or you can fly slower. And yeah, so the important thing is that here there is one thing which is the position where it is, and the other is the speed. And the speed is something that you can have the speed as a scalar vector, so as a number, but you can have also the velocity vector that it has some direction. So this is all these ideas. We are not telling them, we are not using the word as speed or vector or magnitude or direction. So this is all just ideas that are getting inside the brain of the children and getting behind, because they are just they don't need it. They don't need it for playing this game, and it is just something that gets in the background. So this is just the first app that it's free play. Then the story continues, and they say, well, these fire dragons, they eat this instead of meatballs, they eat fireballs, and then you can have the same game. Now it's a bit more fun because you have some goal that you have to be collecting these balls around. So it is just the same. It's the same game, but now you have to collect it, and if you crash against a cloud, then you got restarted, because the Uni Dragons don't like the clouds, and they get back. So now it's a bit more fun, the game. And then on the last game, you have to follow these lines. So this is the Flamma is this lady is a firebird trainer. So she trains the Uni Dragons to make some of this to tell them how to fly or how to follow. And there are competitions in this land, and some wizards compete, and then you have to follow. And here, of course, for children, this is just a basic shape recognition. So you can recognize this is a triangle, this is a square, this is a circle, and you can follow it somehow. But it's very interesting that even if you are not 4 years old and you read this as an adolescent or as an adult, well, you can still get some hints. And it is something that is described on this Educator repository that says, for instance, well, here you are describing the curves constructively. So this is like, well, if you want to draw a triangle, you have to put the pencil on the paper, and then you have to constructively make this line, and then turn this 60 degrees interior angle the complementary, or this 120 degrees to the normal. So you have to go far, go straight, then turn, go straight, and this is something that you can give these instructions here, and it is fundamentally different from the definition by properties. So you can define a triangle that it's a shape where all the sides are the same size and are equal. So that's an equilateral triangle. And the square has 4 sides, and they have the same length, and they also have the 4 angles are equal. And this is a definition by property. And here we have a definition by construction. And this is something that you can experiment, and you can reflect on it, not when you are 4 years old, but if you find this game when you are older, the teacher or the educators can tell you, okay, so what are the ways for defining a shape? And essentially here, we have a parametric description of a curve. So you have a parameter, which is the time, and then for each time you have a point, and it's moving on the screen. So this is a parametric description of the curves, and this is something that you can reflect much later. So this app and this story is not obsolete when you are older. You can always come back and learn a little bit more on this. So the second story we have here is talking to the Uni Dragon. So the story goes like this: that Martina and Leo, they come back to the same field where Flamma was, and they see that Flamma is also conducting or driving a Uni Dragon in the sky. But now she doesn't have the stick on the hand, so she doesn't have the horn. So what happened? And then the Flamma just explains that this poor boy, this poor dragon, lost the original horn because it was flying over a lake, and the horn fell into a lake, and it sunk. So now nobody can drive her, so it cannot be trained. But then Flamma said, well, I will train it anyway. So since I don't have this graphical input, since I don't have this stick, I will use some language. Oh, so what is this language? I will use magical numbers. Oh, magical numbers. How can you talk with numbers? And they say, well, the direction can be described by numbers. And then Flamma shows a little bit of how to use these coordinates without saying coordinates in a moment. And essentially, Flamma explains how you describe vectors with pairs of coordinates, pairs of numbers, and then you can get to this app where you can play with that. And this is the first app that you can have, and then you can say, okay, so I can take number 1, and then the dragon flies. I can say another one, and it flies. And if I put it in the second coordinate, it will go upwards. And if I put in both, so this means go 1 step forward, 1 step upwards, and then you can play, and then you can learn. So what does it take for our children to understand this? So it has to understand this relationship of numbers and lengths, which is something which is really early in the school. And yeah, probably you can even predate. You can do it even before they know about the negative numbers, or at the same time that they know about negative numbers, because, well, negative numbers is just going the other direction. So this is 2 forwards, and instead of raising 2, well, it's going downwards. So this is just a symbol that you can put. So you can do this at the same time that they discover the negative numbers. But usually you don't teach vectors at the same time as you teach negative numbers, because vectors is something much more complex. And when you teach vectors, you want to talk about the length of the vector, and then you want to talk about the Pythagoras theorem, and then you need and you probably want to talk about the dot product and the product of the vectors. So there is plenty of things that you usually want to talk when you talk about vectors. So you delay introducing this idea of vectors to the moment when you have all this background. But here, what we are saying is that, well, for having this just basic connection of pairs of numbers, it's an arrow. This is something that you can do really, really early, and we think it's good to have it really early on the on this non-formal training. It's just a very shallow introduction of vectors. So the story continues. It has some challenges here in the same way. So the first was just a free flight. Here you have a goal to reach the castle without clashing against these mountains or the clouds. Here there's another interesting twist, is that you can add the number and then it just keeps it in the memory. So you can have one vector and then you can have another vector and then you say add. Yeah, it's very naughty to say add, because it adds to the list. But of course, the goal here is that the children themselves discover that this has some additive structure. So that, for instance, if I put these two vectors here, and this is just in the memory, so you tell it to the Uni Dragon in advance, when you say go, it goes these two vectors. And where does it finish? Where is this position that you have at the end? Well, it's of course is the addition of the two vectors. So this vector plus this vector. So it's the addition. So it is not only adding to the list, it's really what you get at the end is the addition. And this is something that is hinted in the story, and it is something that you can kind of help the children discover by himself or herself. This is put on this Educator's repository. There are some hints of what you should try to make them discover this by themselves, not tell them directly.
Danielle,
okay, so yes.
Danielle, I hate to interrupt,
sorry.
but we do need to get to the last two presentations, and we're very near our time limit.
Okay, so this is a bit of the presentation here. Story number 3 is still pending, and number 4 is about implicit surface that I will just show you the picture, and I will let you to discover by yourself. It is this very nice. Let me show you. Yeah, so in number 5, this is for the older children.
Yes.
It is where these firebirds are these microscopic birds that they put themselves into implicit curves, and I think it's very nice that you can discover later. Okay, sorry for exhausting my time. Yeah.
Yes.
Thank you very much.
Thank you, Daniel. Right. And the next presentation is Ricardo Moschetti's presentation. He sent us a video since he is teaching at this time of the day. So Sungwo, please let me share my screen and show the video. Okay, are you seeing the video? Can I go on?
Yes, we are. Please do.
Okay.
We cannot hear it though.
All right.
When you share screen, you'll need to check the share video box in the bottom left corner. I mean, share audio.
Share sound, okay.
Or share sound, yes.
Which is the proper audio setting? Sorry.
When you go back, when you hit the share screen button, and you are selecting the screen, also before you click the final share, in the bottom left corner, there's a checkbox for share audio or share sound.
Yeah, that's on.
Okay, then I don't know what's going wrong. Try it again, and maybe the audio is turned down on the video itself. No, looks like the audio is it.
Yeah, that's on. What else? What else can I do?
Could you dance? Can you dance a jig or?
I can try to share it if I get the permission to share my screen.
Oh, welcome back, Kristof.
Yeah, hello.
Yes, hello.
Hello.
Okay, I stop sharing.
And well, Kristof will be sharing shortly. Until he does, what does this contain? Do you know, Nora? Can you just give us a hint?
Yes, so Ricardo is from Curvilignea, from Italy, and Curvilignea is the partner also in Matina, and their area is cryptography. And yes, the strange subject, which is not taught in the schools, but I would be extremely happy to rather to show you the video than listening to me talking about cryptography.
Okay. Let me. Oh, I'm still not able to share my screen. So if you can make me a co-host, someone from the organizers.
Well,
I'm still not able. Is there someone here who can make me a co-host? Chris, can you give me a hosting rights? Okay, now.
You know, I would love to, but I cannot.
Okay, I'm able to record the meeting now, but I need the permission to share the screen. Mm-hmm. Actually, what if we would go on with Anna until we would sort this out?
Maybe that's what we'll do. Yes, we get you sorted out, and so we'll go a little bit out of our hoped for schedule. I hope Anna is ready and not feeling because we're coming to her suddenly, but I'm trying to give her a moment to catch her breath. And Anna, would you please talk to us about Attractor's role and the Matina project exploring geometry?
So hello everybody once again, and I'm going to share my screen with you. I'll try to share. So can you see my screen?
We see both you. We see the presenter's view, which means we can see your notes and all of that.
Oh, okay. Not supposed to happen. Sorry.
There we go. Now we're set.
Okay. So, let's start by introducing myself. So I'm Ana Cristina Oliveira, and I work in Attractor. And Attractor is a non-profit Portuguese association which aims to, as the name implies, to attract. And in this case, it aims to attract to mathematics. And we started to be very focused on physical exhibits. For instance, these are examples and there are photographs of a big exhibition that we had in Lisbon. It was in the main science center in Portugal, and it was there for more than 10 years. It was called Maths Alive. This is a photo of our exhibition. This is a real Ames room. There are no giants here or the dwarfs. This is ordinary people in an Ames room, and this is there is no Photoshop in this photo. This was an image, a photograph that was taken in that exhibition in Lisbon. But however, for several reasons, at a certain point in Attractor's history, we started focusing on the virtual part. And now we mainly produce contents virtually. And this is our website. It has more than 2,000 pages devoted to popularization of mathematics. It's profoundly illustrated. You can find a lot of apps, a lot of animations, a lot of images. And in the past, our website had a drawback because it was written in Portuguese. But now, due to a collaboration with mathematicians from the Science Center of the Coimbra University here in Portugal, most of our website is translated. So you can now visit our website. I invite you to visit our website, and and see all the materials that we have there. This is just an example of a web page that you can find. This is about mathematical models of shells. You're seeing here a static image, but everything that you find in this web page and in many of our web pages, it's interactive. So you can manipulate, you can see the images, you can try new shells, and you can try to see and to discover how this model works. This is a mathematical model. It's not very difficult. And with this model, you can, just with a model, you can create all the shells that exist in nature. Actually, you can create even more shells that don't exist in nature. But this is just to give you one example of things that you might find in our website. I invite you all to try and to see our contents. We also offer free software. So this is one of the apps that you can find. It's called ATR Mini. ATR comes from a tractor. It is devoted to children up to 10 years old. You can find an app for PC, but this is also available, and it's available for free. It's available in App Store and in Google Play Store. And you can download it and try it. And actually, a funny part concerning this app in particular is that we found out recently from Google Play that ATR Mini is very much imported in China. This was a very big surprise for us. And this is a bit of the funny part of doing things online. You never know where your contents are being used and by whom. And this was a nice surprise. Well, and just to finish the part about a tractor, this is our YouTube channel. You can also find it in our website. There's a link for it. It has more than 20 films, small films, we call them MATLabs, and about different subjects. One of them is symmetry, but other subjects also. And I invite you to see our films and to see our experiences and our proposals that are there. Well, and finally, here are our references. So again, we have our site, you have our YouTube channel, which I mentioned just before, and of course you have our Facebook, and then again our email if you want to contact us or if you have any doubts. So so our main role now, going to Symmetry Fair and to Matina project, our main role in this project is, and our main contribution is the symmetry part. So we were responsible by Symmetry Fair and by the contents which are related to symmetry. And why did we choose symmetry? Well, we had two goals. One of our goals is to help visitors in Matina world to deepen various concepts that arise from their own empirical experience, because symmetry is something that comes a lot from our experience. But we want to deepen and to and to relate them to mathematics. Another one of our goals is to do in a playful and interactive way to make visitors discover what symmetry is, and also to help them distinguish between different types of symmetry. So this was our goals when we started the symmetry part in the Matina project. Well, I will just interrupt the sharing for a moment because I would like now to share my, okay. I'd like to share, let's share again. Oh. Okay, so I would like to share the website. Are you seeing the website?
Yes, we are.
Okay, okay, great. Okay, so I won't have much time to show you the symmetry part, but I can show you some examples. And my idea now is to concentrate in one of the stories. And the story that I would like to show you is, I'm going now to the, sorry, not here, to the symmetry part. And I'm going to focus in the story Stamping Freezes. This is a story for 11, 14 years old, but it can also be explored by other age groups. So I'm just going to open now. So what happens in Stamping Freezes is that when Matina and Leo arrived to Symmetry Fair, they get to know the wizard who is responsible for Symmetry Fair. And here is the wizard. And the wizard is stamping beautiful friezes in the roads, but he's stamping them in a traditional way. And we can see how the wizard is stamping. I'm just going, okay. So if I open this film, you can see that he's stamping like this. So you have to imagine that the board has ink on it, and he's stamping like he would do if he had a traditional stamp. This is what he would do with a traditional stamp. Well, but meanwhile, the wizard has to go to the castle, and he has to go to the castle because the ink of the board, this board, is finishing. But the board is difficult to transport. And why is it difficult to transport? Because it's big. And the wizard is using his magic broom. So they decide to roll the board and to stick that roll in the wizard's broom. So they make a roll. And while the characters are distracted talking, they don't notice that the roll starts rolling and is stamping a freeze. So we can see it here now. So the two characters, Matina and Leo, are very worried because the roll started to roll. But on the contrary, the wizard is completely thrilled. And he's thrilled because the roll is stamping the freeze automatically. There is no need for any effort because it's doing it by itself in a much easier way. And why did this happen? This happened because the roll, the cylinder, is the good stamp for freezes which only have translation symmetry. So we can go on. So now they are very happy because they can stamp freezes very easily. So here you can choose an image you want. You can create a cylinder, and you have to imagine that the cylinder has ink on it. And then you can see the creation of a freeze. Just have to press this button. You see the creation of a freeze, and this freeze will have as a motif the image you chose. And now you can choose the image and print other freezes. And this will lead to several discoveries from the main characters, Leo and Martina. For instance, they notice that, okay, so the wizard now goes to the castle, and they notice that the freezes, they are an important feature in the freezes. There are freezes that have symmetry axes, and there are freezes that don't have symmetry axes. They also discover another interesting feature, is that in the freezes, if you look to the freezes which have symmetry axes, there are three kinds of freezes. There are the ones which only have vertical symmetry axes. Then there are the ones which only have horizontal symmetry axes. And then you can find the ones that have both kind of axes. So they go on experimenting and doing a lot of trials. They stamp and create new stamps. Just go forward. They also notice that if you want to stamp a frieze that has both vertical and horizontal symmetry axes, you don't need a roll. You can do it only with a board. The board should have ink on both sides. And if you use these movements, you can very easily imprint a frieze which has both vertical and horizontal symmetry axes. And so they go on with making a lot of discoveries, which I invite you to test. They discover, for instance, that a frieze can have rotation symmetry, like this one. They discover, well, they go on with stamping friezes and in different ways and finding new stamps. And later on, they discover that a frieze can have glide reflection symmetry. So we can see it here, an example of a frieze that has glide reflection symmetry. So if you reflect and you move a little forward, the frieze goes onto itself. Well, they keep on making experiments. They discover that all friezes have translation symmetry, which you can see here. Sorry, just want to go this one. And finally, they discover that they arrive to all the different types or symmetry groups that exist for the friezes. And there are only 7 types of friezes. This is a theorem, and they arrived to the 7 types of friezes. And now, when they arrived and they have split the friezes in different bags, they can now choose for each bag the symmetries that exist in the friezes in each bag. For instance, if you choose this bag, this is a bag which has translation symmetry, which would have horizontal reflection symmetry, and also has glide reflection symmetry. And then they can move on and do the same for all 7 bags, which correspond to the all 7 types of friezes that exist. So this is one of the stories. I don't know if I have more time or not. I don't know how I'm in time. Sorry.
We are in general a little bit out of time, but if you show still what you want, quickly, that's fine.
Okay, thank you. So I'll just show a very little part. I invite you all to try all the stories. As I mentioned, I won't have time to do it all. I'm just going to show a bit of the second story. So here, Martina, this is for the 7-10 years old. So Martina again arrives to Symmetry Fair. She's invited to play a game related with rosettes, but she does not remember what a symmetry axis is. So she can make some trials by dragging a mirror. For instance, here, if you drag the mirror and you put the mirror here, you can see that this image has a reflection symmetry. It has a symmetry axis. And then she can go on and play the game. And there are several games related to rosettes. I just will show one of them. But again, I invite you all to try this game. For instance, here, she has to put the rosettes in the good bags. And which are the good bags? Well, now we are dealing with rotation symmetry, so we should count the number of rotation symmetries that this image has. And you can do it by dragging the image and seeing how many times these two images, the one is underneath and the one which is above, how many times they overlap. And if you do that, you can find that this will happen 3 times. So this bag, this rosette, should go to bag number 3. Okay, this is just a game. And well, just to finish, because I know we are short in time, I'd like to show you just one more app. At a certain point, Leo, Martina's brother, and Martina decide to continue exploring all the fun and all the diversions that exist in Symmetry Fair, and they decide to enter a mirror maze. And I'm just going to show a bit of this mirror maze. So when we enter this mirror maze, which is here, you have to solve a maze. And this seems a very easy and ordinary maze. But when you start solving it, at a certain point, you cannot see your path in the left. But you are in a magic vault. Symmetry Fair is a magic vault. And you have on your right a mirror, a magic mirror. And you can see the image in the mirror. So to guide yourself, you have to follow the reflected image which is appearing on the right. And in this way, and with this app, you can, in a playful and interactive way, to explore and to train notions related with reflection. So this is, for instance, one. And then the magic mazes are getting more and more and more difficult, okay? So this would be a mirror maze that you had to solve, and the mazes get more and more difficult. And then we have a similar one, but instead of a mirror, what you have is a maze which is rotated. So this is a rotated image of the original mirror. I can see the original mirror here. And it was rotated by half a turn, so 180 degrees. It was rotated in this point. So now you have to solve the maze by looking to the rotation image. So now in a playful, again, and interactive way, you can train properties related with rotation by solving mirrors, okay? And again, the mirrors get more and more difficult. Okay, so maybe I can stop. But my idea is that, well, I'm just showing a bit and in a very quick way because the time is limited, but I invite you all to try our stories and to read our stories and explore our films and explore all our apps. Okay, thank you.
Thank you, Anna. Thank you very much. We appreciate your hard work on this. Those are beautiful mazes. I'm just fascinated by the idea of the mirror maze and the half-turn maze. Those are great brain training things for working on strengthening the corpus callosum as well. So it's wonderful stuff. So we have one more video, but conscious of the time, I'd like to say, if you need to go, if you would like to, if you feel a need to leave, you are welcome to leave. For those who want to stay, I will press play on Ricardo, his video on the cryptography, but please, our time is up. We are now almost a full half hour beyond what we promised to keep you, and we will. This is a 14-minute video, and I'll let it play, and then we'll have a little bit of closure afterwards. So, all right.
Hello everybody, and thank you to all the people of Experience Workshop for inviting me here. I am Riccardo for Curvilinear, which is the Italian partner of the Mattina project, which we are here to present today. Oh yes, so I forgot, I said Mattina. Let's do this, and let's come here in this beautiful land together. So I don't know you, but lately I've been here so much time, this is starting to feel like home. So, Curvilinear is a cooperative company based in Italy. We are in 4 people, 3 mathematicians and 1 expert in communications and museum science. We are Alessandro, Cristina, Filippo and me. And Curvilinear was founded around 2014, so it has been 7 years in which we are communicating mathematics, even if we started before. We started around 2012 doing exhibitions. So we like talking about mathematics. We love communicating, telling people about how beautiful mathematics is, and doing so we participated to many science fairs, many events in Italy in these years. For instance, we went to Festival della Scienza of Genoa, to Bergamo Scienza, to Festival della Scienza of Cagliari, and also we interact with many schools and university, for instance in Milano, in Pavia, and also in Trento. So, I was saying we like to talk about mathematics. We do so in many ways. One of these ways is through exhibitions. Like we prepare exhibition about a certain topic, and here you can see the footage about an exhibition called Rette Rotonde, which means curved line, which is an exhibition about hyperbolic geometry. It was very nice because hyperbolic geometry is very complicated from the point of view of mathematics, but there is this strange idea in which you can find triangles with the sum of the angles, which is lesser than 180 degrees, which it's so nice to tell people, because people at the beginning does not believe, and then you tell them, oh yes, but we can do this construction with, we can also do it with kids, and in the end they are saying, okay, yes, it's possible to do that. And also here is some other footage about another exhibition. This was about waiting times and probability. It was called A che ora passa il mio autobus, which means when does my bus arrive? And you can see many people were entering, asking, yes, why is my bus late? And it was so nice because it was telling, no, it's like a question of probability. It's not that it's late, but you feel it's late. And so you see, mathematics is so related also with the ordinary life of every day. So in these exhibitions, we used a lot computer and program we develop and some software to show mathematics to people. And here is another project. It was an exhibition called Uno per tutti, tutti per uno. Oh, this exhibition is nice because we thought when you use a computer, you always are one people using the computer or 2 people using it together, but it's very difficult to make the use of computer a group activity. So we built this, this gamepad, but not one, not 2, not 3, many, like 32. And we start wondering why, if I can like make 32 people play the same game together, like really together at the same time. And we did that in this exhibition. Was basically about game theory and a lot of exercises in which people has to communicate using mathematics, and it went very well. Like personally, it was like the first time I saw many people together interact with the computer as a group, like streaming together when the game was not going so well, and it was very nice. So to end this presentation of Curvilinea, like these other 2 footages of some project you can find in the imaginary platform. This one is a movie, is a video. It's called Patterns of Nature, and it's about the relation between fractals and nature. It's like a movie. And this other one, this is a nice game. It's called Fly Faster, Fly Shorter, and it's a game to understand the distortions we have on a map. We thought about what if we make people drive planes, but not on the globe, on a map. So you see the plane which changes size, and like the routes of the plane with like are not straight line, but sometimes has angles. And like it's so nice because you start and you just play a game. It's not about thinking about mathematics, it's like playing a game, and while playing people start to understand about mathematics because they realize, oh yes, what's happening? Why is it changing size? And then you tell them it's not changing size, it's the map which is distorted. So here was our quick presentation of us. And so let's move about the topic of today. So let's move about Matina. So for the Matina land, we prepared the part about cryptography. From one hand, it's like difficult to explain because cryptography is it's very technical somehow. You have rules to follow, you have a lot of difficult mathematics involved. But on the other hand, cryptography is like about communication, and mathematics is about communication. Like I feel when you do mathematics, even as a mathematician, you basically do a dialogue between 2 people, between you and who you are reading, between you and the public of an exhibition. And the cryptography is really understanding how people communicate. So that's the reason why we choose to include cryptography in the Matina project, because like through stories and through tales, like tales are also a dialogue somehow between us, or between the reader and the kid, or like something like that. So why don't use like stories and dialogues to introduce cryptography, which is a dialogue as well? So at first, the first idea for like really young kids, it's like really to introduce the idea behind cryptography, that is like there is a concept you want to communicate in secret, and there is the way you communicate this concept. So you have to establish a relationship between the thing you want to communicate and how you want to communicate that thing. And the first story you will see, it's about this concept to create this relation. And you see, this is the basis for cryptography, but it's also the basis for communication. Like if me and you establish that yellow means a certain color, then we have formed a part of this relation. So it's something we humans, as humans, we do every time. And so it's nice to tell this inside the story. So then there is the second story and also the third one, which are based on the same concept, which is a cipher. Is a famous cipher called the Kaiser Cipher. And in the second story we explore this cipher, and in particular we explore the dynamic of cryptography. So the idea is that cryptography is not relying on the secrecy of the method. So the way we use to start from a text and modify this text to encode is public. This is called the method. And then there is the key, which is the piece of information you need to pass from the clear message to the encoded message. And so in the second story, we are speaking about this, so about the fact that in cryptography you have to establish a method and to find a key, and the cipher we use for that is the Kaiser Cipher, and we propose this cipher to the public in a visual way via this jewel, which you can rotate in the apps and you can see how it works. Then there is the third story, and in the third story we go a bit deeper in explaining this part of cryptography. So we first go deeper about the Kaiser Cipher. We talk about what if you do the Kaiser Cipher twice, and this relationship with between the Kaiser Cipher and doing sums modulo a certain integer. So this is very nice because we introduce a topic of algebra which is very difficult, but instead of introducing it directly, we need to understand how to calculate things, we start by the cipher, which is this object, this jewel, and try to understand how it works. And at a certain point we start wondering, oh yes, but this is very similar to doing sums. And it's doing sums, but not exactly the sum we are used to. It's more like a sum on a clock. But then, for instance, sums are commutative and sums are associative. So basically it's no difference of doing twice the Kaiser Cipher or doing it just once. And then we going even deeper to introducing a cipher called the Visionaire Cipher, not in its full power, let's say, but it's just the Kaiser Cipher done on even and on odd letters. So this is a way to use the Kaiser Cipher, but in a way which is way more complicated to decipher if you don't know the key. Lastly, there is the fourth story, in which we try to introduce the concept of public cryptography and the public exchange of keys. We started from the importance of communications in life, not in mathematics. And then we are in a topic about cryptography, which is important also because of the modern world, because this part of cryptography is used so much in internet, when you do payments on the web, and yeah, I think it's a good way to begin talking with students, for instance, about the behind the scene of the operation they, for instance, do on their mobile phone, let's say. And so in this story we start to explain some of these methods and to start by wondering, okay, but what does it mean? What does it mean for a method to be secure? What if some people is pretending to be me with something else? What happens? And you can find this in the story. So this was a
Dapat dengar kah? Masih tak dapat dengar kah?
Not to spoil it so much. And while I was talking, you could see some footage directly from our stories and our apps. And I hope so much you will find them interesting. You will try them, and I hope you will like the world of Matina and also the world of Buccaneers Island, which is the name of this part of Matina devoted to cryptography. So here was Ricardo from Curvilinia. Thanks to everybody for watching this. Bye bye!
Thank you a lot for Ricardo, and thank you a lot for the patience of everyone. Sorry about the tremendous overtime. Actually, this seminar is usually 2 hours and 50 minutes long. So apparently we are using the whole time, though we didn't expect it. And I think Nora still would like to highlight the graphical artists who were working on this. So this visual world is created by one of the contact of Experience Workshop. Nora, can you share her webpage?
Yes.
And then I think we can jump into the discussion with all of those who had the time and patience to keep with us.
Okay, do you see my screen?
Yes.
Yes, we do.
Okay, so the illustrator of Matina is called Cecilia Shimoni, and she is a Hungarian illustrator, originally a cultural anthropologist. And we found her after a longish search for an illustrator who would go through all the stories. And here, this is her page. So if you would like to remember her name, I can also name and the page. I will put the link in the chat. These are some examples of her books which she has illustrated. That's all in Hungarian up to now. She only worked in Hungarian. And yeah, I encourage you to take a look at this page and also visit her Facebook page. You will find the link there to the page, and just take up contact with her if you are interested.
Yes, we were really happy to provide this creative, colorful, and maybe a little bit more not standard artistic view, which makes a little bit different than from the usual digital apps visual words. I think we can all agree in that, and that was also pointed out by Carrie, that it's also a little bit surprising to see on the screen of this kind of sort of old school images, but in the same time it's maybe also helps more the imagination to fold out and also to have this aesthetic quality what we really would like to provide to the children and the parents. Okay, it was very much a long session, so the floor is for Chris and all those who want to get into dialogue.
Yes. Are there questions from anyone regarding specifics of these topics? We've seen some very fascinating ones. Raise your hand or speak up.
Jada is raising hand, as I see.
Hello, Chris.
Hello,
maybe
Jada.
I'm curious, to understand, because about the website and how it's been built. So which is the software? Because before it was Flash to have these interactive stories on the web. But now, how is designed? I don't know if the question is here.
I think Daniel is the right person to answer this question.
Yes. So today we didn't have anyone here from Bragi, who is the fifth partner on this consortium. They are the technical partners, so they prepare all the platform. So it's all modern web technologies. So it's a lot of JavaScript. So the platform itself, so what you see there with all the characters appearing and all the stories and everything, is all based on I think it's Nuxt, it's called the platform. I mean the technology that it's under the hood. I don't know. I can put the GitHub repository. So we are doing all on the open. So All the code is
Thank you very
available.
much.
For the
Please.
apps themselves, they are developing by each of the partners. So it's different technology, but it's everything. It's JavaScript. So the Flash is a dead technology, and now it's everything on JavaScript.
Okay, thank you very much.
Other questions? Yes, Emily.
I would like to remark that all presentations for me were very interesting, and I can use this for training of different kinds of university students. We have got teachers in mathematics, secondary and high school. Also, we have got engineers, and also no, this is industrial design, and will be for them very good examples. And also we have got teachers, preschool and primary school teachers, but till now I didn't see the examples, some examples for them. Is it possible for students to make a registration to go in and to use for some classes? Or just one person teacher can be registered?
Excellent question. I don't have an answer. Danielle?
So Nora, what you say?
Yes, you don't need a registration to use this page. So if you just, you can right now go ahead and use it, and students can go ahead and use it right away.
Okay, thank you very much.
Welcome.
We will use in this first semester, this academic year, and I will inform you about the results.
Beautiful. I have a question as well. Does anybody in the project have an idea of what comes next, or what other lands will Mathina be visiting in the future, and what sort of mathematics will she be engaging in?
I would love to have a Mathina 2 project, like another funding from European Union or something. So if not, the problem is of course it's all this funding and trying to find how we could either sell this or have some kind of sponsor that can help. We have some proposals for having more lands. So yeah, we are thinking, because this Erasmus Plus project is finishing right now in May.
Also, this was a product of a specific set time project, and it's wrapping up now, and this is coming online and being left out in the universe for people to enjoy, almost simultaneous with this seminar. Am I understanding?
Yes, more or less. So we are still doing some workshops, and we at least in Germany we will do some workshops also in June. But yes, the funding of the project, so this was an Erasmus Plus project. This is funded by the European Commission, and has been 2 years, and now it's finished. So now we are presenting it. They will evaluate if we did a good job or not, and all the content is released under open licenses, so everybody can use it for free, and everybody can build on that. So one question, for instance, is if we want to make more stories, we will need to have some consistency for the illustration. So we could hire again the illustrator, or in principle, is it possible to have another illustrator to make something similar? I mean, there is no copyright on that. But yeah, but it will require some kind of planning. So to see who can work on that or how can we organize it. So for the moment, it's only going to be these 4 stories.
Okay.
Also a phase when we.
It is very hard work that you did, and also very professional, hard programming, and good mathematics. So I hope that you will continue this project in the future.
Thank you very much. And I think we would be really happy about receiving feedback if you go on and try with your students or families or friends one or the other story or app. Please feel free to send us feedback, any type of feedback, because then we will be it will be easier also to go on. And of course, we are ready to correct all the mistakes that which still remain there in the applications. Thank you for writing us. I put in an email address where we are waiting for feedback.
I would like to say something too. Thank you very much to my very good friend Nora and Kristof. Happy to see you here, and I found it very interesting. And for sure I will use this Matina with my students. Now the school year is ending, but from September we'll be back to school and we will use it, and I will let you know what happens. And take me into consideration if you go with Matina 2 for a new Erasmus project. We will be very happy to join and to develop this idea or something else. So thank you very much to everyone.
Thank you, Luisa, for coming.
Thank you, Luisa. Ciao, Java. Well, all right. I think at this time it would be appropriate to hand this back over to the folks there at 4D Frames, our hosts in South Korea, Seoul. Thank you very much. Please, back to you.
It's 4:30 in the morning. Where'd the time go? Oh my God.
Thank you so much once again for leading this seminar as a moderator in such a late hour. Thank you so much as always, Kristof and Christopher.
Thank you very much, Sungwo, Hogul, and whole 4D Frame team. Thank you for taking care about our security. It might was a lot of work for you and also a lot of time for us to enter, but I think it's more important that we could have this calm dialogue in this really friendly manner. Thank you for all who contributed to that. And you are welcome to stay in touch. So please subscribe, follow these Facebook pages, and let's get involved into the upcoming meetings. And also please inform us about your events. Okay, so we want to be part of your events too. So let us know if something is going on in your countries or if you are doing something which you want to share with us. Thank you a lot.
Thank you so much.
Thank you.
Goodbye.
Bye.
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 Please join our session on June as well. It'll be live. It'll be on Eventbrite. Thank you so much again for joining us today. Have a wonderful day or have a wonderful night wherever you are. Have a great day. Thank you so much.
Sleep with the cows and dolphins.
Yes, I was thinking the cows and dolphins. Thank you.
Great.
Good night.
Thank you. Good night.